All right, so let's take a look at two examples applying the rational root theorem. Okay, so this one asks you to factor completely, find all the zeros, and sketch. All right, so looking at this problem, right, typically when you see four terms like this, I would try factoring by grouping. But if you play around with these numbers here, you're clearly not going to be able to factor by grouping. Okay, so factor by grouping doesn't work. We're going to use the rational root theorem. Okay, so my possible zeros, if I just list them all out, are factors of 15 over factors of 1, right, or positive or negative 1. So really, it's just going to be plus or minus 1, 3, or 5. Those are your possible rational zeros in this particular problem. And, you know, out of the interest of time, right, you can start guessing and checking using synthetic division, right? But I'm just going to start with negative 1 as one of my possible guesses. Okay, so negative 1, 1, 17, and 15. Make sure all the coefficients are not missing any placeholders. So over here, I'm going to write negative 1 plus 0, which is negative 1. Negative 1 times negative 1 is positive 1. If I add this, I'm going to get 2. Negative 1 times 2 is negative 2. And negative 1 times 15 is negative 15. Okay, so I got one of my zeros. In fact, because I went from an x cubed to an x squared, I can essentially stop, right? So this is negative x squared plus 2x plus 15, right? This is my depressed polynomial, right? Okay, so I'm asked to factor completely. So I know negative 1 is going to be one of the factors. And I need to continue on by factoring this, right? So over here, what I'm going to do is factor out this negative 1 over here. And we'll have x squared minus 2x minus 15. And if you factor this, right, it looks like this will be x times x. And I'm going to have 5 and 3 over here. And I want a negative inside. So negative 5, positive 3, okay? And we said this was one of the zeros, right? So you want to include that. So x minus negative 1 is x plus 1. So for part A, this will be your final answer when we factor the polynomial. Okay, so make sure you factor out that negative 1. All right, well, once you have part A, right, part B, it's fairly straightforward. You could do in your head, right? One of the zeros is going to be 5, negative 3, and of course negative 1, right, which we got by using our rational root theorem. And then, of course, a reminder on how to sketch, right? The leading coefficient, a sub n, in this case, is less than 0, right? The degree of this polynomial is an odd number, right, because it's a cubic. And that means our m behavior is going to be rise on the left, fall on the right. And we also have a y-intercept in this problem, right? The y-intercept in this case is just 15. Okay, so you could also find by f of 0, whatever f of 0 is. In this case, it's 15. All right, so just a quick sketch. There's my y-intercept going from left to right. I have negative 3, negative 1, and positive 5. And there's my m behavior. The multiplicity at all these zeros right here are 1s, which means it's going to cross. So cross, cross, intersect the y-intercept, cross. Roughly, your graph's going to look something like this. All right, so there's part 1. Let's do another one here. Part 2. What if we have something raised to the 5th? F of x is equal to x to the 5th plus 5x to the 4th minus 5x cubed and minus 15x squared minus 6x. All right, so before you start saying, oh, it's going to be factors of 6 over factors of 1, notice there's an x here, right? So this is actually not your constant term. And so before I even begin, what I'm going to do is factor an x. And I have x to the 4th plus 5x cubed minus 5x squared minus 15x, right? Minus 6. Okay, so you already know one of the zeros is actually going to be 0, right? Because x, if I set this guy right here equal to 0, I'm going to have a 0, okay? So actually, it is factors of 6 over 1, but make sure you are able to factor out GCF before you begin on this problem, all right? Okay, so for part A, we're asked to factor, right, completely. So we need to factor what's inside here. And, of course, the way you do that, of course, is use your rational root theorem. So, again, my possible zeros are factors of 6 over factors of 1. So plus or minus 1, 2, 3, or 6, right? I showed a little bit of less work on this example, and so you can do so as well. And the first example I did in the other video was just to remind you guys, what are the possible zeros. All right, so out of the interest of time, right, instead of doing a bunch of guessing and checking, I'm just going to give you one of the zeros. One of the zeros in this problem is just going to be 2. So let's write it out. 1, 5, -5, -15, -6. And let's do our synthetic division. 1 plus 0, that's 1. 2 times 1 is 2. 2 times 7 is 14. I add this, I'm going to get 9. 2 times 9 is 18. -15 plus 18 is -3. And over here, positive 3. 2 times 3 is 6. And I end up with this depressed polynomial. Okay, so you have to kind of keep track of what is this, right? Is it x cubed, x squared? Remember, we're doing long division or synthetic division on this, right? So x to the 4th, this actually becomes x cubed now, right? And as you know from synthetic division, right, you can continue, right, because you want to go all the way until you have a quadratic. Once you have a quadratic, you can use, quadratic formula or completing the square, right? So you have to keep going using these original ones. And so the next zero that I'm going to give you is going to be -1. Okay, so obviously when you're doing your homework, right, you don't know this, you're just guessing and checking. So 1 plus 0 is 1. -1 times 1 is -1, that's 6. -1 times 6, that's -6. And -1 times 3 is -3. All right, so now we have a depressed polynomial of x squared plus 6x plus 3. Now, we're asked to factor completely, right? And you take a look at this for a minute, right? Factors of 3 that give you 6, it's not possible, right? And so you can, write out part A over here. F of x is going to equal, don't forget this original x over here, is going to be x times the zeros that we had, right? X minus 2 was one of the zeros, or x minus -1 is x plus 1. And then, of course, we have this guy right here, times x squared plus 6x plus 3. Okay, so you can't factor this any further. That will be your solution for part A. All right, now part B, right, finding all the zeros. We already found 2 of them, right? We found 2 and we found -1. So my zeros are 2 and -1, right? But then we still have to figure out this guy right here, our quadratic, which is not factorable, but of course we could use completing the square, or we could use quadratic formula. Okay, so I think you guys have had enough practice of quadratic formula. This one, I'm going to review how to solve using completing the square. Okay, so the way you do that, of course, is you want to isolate this term right here, right? And then, of course, you can complete the square from this step. Okay, so 6 divided by 2, that's 3. 3 squared is 9. So if I add 9 on this side, I'm going to add 9 on this side. And this becomes x plus 3 quantity squared. And then you solve using square roots. Take the square root of both sides. You get x plus 3. Make sure you write plus or minus root 6. And x is going to equal -3 plus or minus root 6. Okay, so on a quiz or test, I want the exact answer, because I know you could just look this up on, Desmos and whatnot. But make sure you know quadratic formula. Make sure you know how to solve using completing the square, okay? All right, so these are the zeros. 2, -1, -3, plus or minus root 6. And then last but not least, right, you can do a little sketch over here. The leading coefficient in this case right here is a positive number, right? A sub n is positive. Your degree is 5, which is an odd, right? So it's going to fall on the left, rise on the right. And if you're wondering what these zeros are right here, right? We have zeros of 2 and -1. So actually, let me just give you the approximate value so we kind of know where we are on our axis. Okay, so 3 plus root 6 3 positive root 6 is going to be negative 0.551, and then negative 3 minus root 6 is going to be negative 5.449. All right, so if you use a calculator, these are the approximate values of those zeros, okay? All right, so quick sketch, right? We have a 0 right here. You can write negative 3 minus root 6, or you can write negative 5.449. Doesn't matter which one you choose. There's a 0, and then we have a 0 at negative 1. We have a 0 at negative 0.551. We have a 0 at 0. And we have a 0 at positive 2. All right. So we said fall on the left, rise on the right. And, assuming that this is, it's not factorable, but we know the zeros right here. If you were to be able to factor it, right, you're going to get these numbers right here. So these guys are also going to be crossing, okay? So at negative 5.49, it's a cross. Multiplicity is a 1. At negative 1 over here, right, multiplicity is a 1. Multiplicity is a 1, right? These multiplicities are 1. And as I mentioned, right, these zeros yield this. And if you were to able to factor it, right, you would end up with these numbers. These multiplicities are also going to be 1. So everything's going to be crossing here. Cross, 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 and then cross. Okay, so roughly, this is what your graph's going to look like. I know it gets really, really messy, but it's a good review on, putting everything that we've learned together, right? Finding all the zeros by using the rational root theorem, factoring completely, and also, sketching it here at the end.